in terms of magnitude, the rate of change of flux over time. In this case, we only have one turn, so n is 1. Is it clear? You can analyze in this way also. Okay? And in terms of which n is at a higher potential, you can also analyze without looking at the electron. You can just apply Lenz's law. Let's just discuss. I think in this case, this one I'll leave it to you to try out if you want to. Find what is the total flux. Then find what is the rate of change of flux. By the way, do you know how to find the total flux through this loop? When B is changing. Of course, you cannot take B times A because B is not a constant. You have to divide this into many infinitesimal elements like this. And find what is the flux through one such element. Because across one such element, the distance x from the wire is the same, isn't it? So B is a constant over here. Then after that, you perform an integral. You'll find the total flux. Then after you obtain a total flux, you do a differentiation, you get the EMF induced. Is it clear? Oh, you can try that. No? So this will be your dA. Then your flux is equal to B dA integral from here to here, from one end of the wire to the other end of the wire. Alright? Now, we can also know which one is at high polarity by using Lenz's law. How do we do it? When this conductor is moving upward, what happens to the flux through this loop? It's getting smaller, right? Because the area shrinks. So the flux is pointing in because B is in, but the area gets smaller, so the flux gets weaker and weaker. So now we have a decreasing flux. According to Lenz's law, the induced flux must be pointing in because it's a decreasing flux, isn't it? So therefore, the current must be flowing clockwise. Do you all get that? Do you all get current clockwise? You see, the flux is decreasing with time pointing in. So the induced flux must be pointing in to reinforce, to prevent the change. So the induced flux must be pointing in, then current must be clockwise. So in fact, using Lenz's law, if I have a loop like this, I know current will flow in this way. Then the thing is like this. When current flows in this way, which terminal has higher potential? Can you remember from any of your circuit knowledge? Left or right? In fact, we know the answer is left, right? But are you able to reconcile if you look at the current flow? Now, one thing very important you must take note is that this conductor is not behaving like a resistor. This conductor is actually behaving like a battery. If you think of it as a resistor, then you'll see that this is high because current enters positive terminal of resistor, right? But it's not a resistor, it's a battery. And when you have a battery, what happens to a current? Current will be flowing out of positive terminal, isn't it? So therefore, if you remember this is a battery, then you know when current flow like this must be high. So it's consistent with what we've deduced. Are you all familiar with what I'm talking about, by the way? About some of this circuit knowledge? Yes. How current flows in and out of battery and resistor. Okay. Right. So we can move on